LeetCode problem number 39, combination sum. So this problem gives us an array of distinct integers called candidates and a target integer called target. So our job is to return a list of all unique combinations of candidates where the chosen numbers sum up to the target. So there are also some other rules, such as we can return it in any order. The same number can be used a lot of times. Two combinations are unique if the frequency of at least one of the numbers is different. And the last one is just for the test case where the unique combinations will be no more than 150. Okay, so this problem requires backtracking because we are going to try out a lot of combination. And to do backtracking, we will have to use recursion. So in my recursion function, I will be using the candidates vector. This is what we'll be receiving from the problem. I'll have a current vector. So this current vector will store the possible numbers in the possible candidates that may sum up to target. When that happens, we will push current into result. So you can see here result is a 2D vector. This is what we'll be returning as the answer. And then we have a index. This index shows where we are at with our candidates. And we also have a target, which we receive from the problem, and a sum. This sum will tie to our current, basically mean that the sum will keep the sum of all the numbers in the current. Okay, so when the function is first called, before that I have a simple example here where we have candidates 1 and 2 and the target is 3. So when the recursion function is first called, our index is 0, our I is 0. So when that happens, this if statement does not trigger because our sum is 0. This if statement does not trigger as well because I is less than candidate size, which is 2. Let's take a look at this while loop then. So while the sum plus candidate I, which is 1, is less than target, which it is, then we increment our sum. So sum is now 1. We push back in our current, and then we recurse. Okay, so I'll mark this recursion as from the while loop because we have two parts in this recursion that we will call recurse, and it might get confusing, so I'll mark this as while. Okay, maybe I'll do like this instead. I plus 1, I is now 1. Yep, I is now 1. And if the sum of the target is more than target, we will return, but since it's not, so we don't do anything. And if I is more than or equals to 2, we will return or push back, but since this is I is still less than 2, so we don't do anything here. And while the sum plus candidate I is 2, so if 1 plus 2, it will be less than or equals to 3, which it is, so we increment our sum. Sum is 3, current we push back, and then we enter another recursion. So while I equals to 2 over here. Okay, now since sum still is not more than target, but I is now equals to 2, right? That means we have reached the end of our candidate list. So here we check whether or not our sum is equal to the target, which is it is, since sum is equals to target 3. So when that happens, we push back current into our result, and then we return. So this return will return over here. Okay, and since this was in a while loop, when we return, we exit over here with I being 1. So we try to increment sum plus I again. Since now we cannot plus another 2, right? We cannot plus another 2. So what we do is we exit this while loop and we check over here. And in this while loop, if you can look here, we have two conditions. One is that the current must not be empty, and the back of our current must be the current candidate that we are using, which is 2. And since it is, we will have to subtract sum and pop back from current. The reason we do this is because this is the backtracking. This is our backtracking method. So what we're doing is we remove what we have tested before. That means this current. Just now you see that is a dead end. So we have to backtrack to where we came from, which was at 1. Okay. When that happens, we recurse again. So the reason why we recurse here, even though it looks like we don't need it, it's to deal with conditions such that, let's say there's a different target, and in our candidates we have a 3 instead, something like that, right? That means we have to skip past this 2. Okay, but since it's here, so I'll just do it anyways. So the end of our function, this is where we are going to call this recursion. So I equals to 2 now, equals to 2. Okay, and then the sum is still less than target. This does not trigger. Now sum, actually this does trigger because I is equals to 2. Since our sum does not equals to our target, we just return. Okay, while that is done, since we have reached the end of this recursion, so here we went back to our roots where I was still 0, and here we try to increment our sum again, right, with our candidates I equals 0. So I plus 1, we'll get 2. Over here, get 2, push back our current, recursion with I equals to 1. Now if we look, since we cannot add another 2, since our sum was 2 already, if we add 2 will be 4, so we do not add that. We don't enter this while loop, we recurse again. Now I equals to 2. Since our sum does not equal our target, we just return here, and then we return here, and then we try incrementing again. Remember, this is from our while loop. We try incrementing again. Plus 1 is equals to our target. Okay, we recurse. I equals to 1. Cannot push, cannot pop. We recurse again. And now, since I is equals to 2, and our sum is equals to our target, so we push back our current, which is this, into our result. And then of that we return. So return here, and eventually we cannot add another 1 behind this. So we exit this while loop. Over here we pop back all of the 1s. Minus 1. So this will give us 0. So we are back to where we started, which is common for a backtracking function. And when that happens, what we will do is we will try to recurse where I equals to 1, and this time we try with 2 instead, right? But since that I equals to 1 is 2, and there's no numbers behind 2 that can fulfill our target 3, so eventually this recursion will exit as well, right? So when that happens, all the functions settles, we exit this recursion function, and then we return our result, which in this case would be 1 2 and 1 1 1, right? There are no other combinations that satisfies our target. Okay, hopefully my explanation is clear enough. That's all I have to show. Thanks.